Happy Wednesday, everybody. Welcome back to the ENCOR study group. We are moving into Blueprint section 1.3 today, which has to do with the on-prem versus cloud deployments is how it tells it out in the blueprint. We're going to be exploring exactly what that means for a lot of us network engineers. We don't have a lot of data center experience, and so it's interesting that Cisco tossed this into the ENCOR blueprint, but they did it with a reason, and that is because we as network engineers, if we want to be, complete network engineers able to solve any problem, we need to understand what's going on inside the data center so that when our organization has problems around the networking that's in there, that we can help with that. And more organizations are going to have not only their data center to worry about, but also a cloud deployment. So again, it is mission critical that we as network engineers understand what's going on, number one, in the data center, what's going on in the cloud, and kind of how it all bridges together. So stick with us today. We're going to have a lot of fun unpacking this concept of cloud versus on-prem deployments and looking at, again, as network engineers, what we need to know about that. So here's our agenda today. We are going to be looking at, where did it go? There it goes. We're going to be looking first and foremost at what a virtual workload is. So again, I'm going to approach this from the perspective that, you may not have a whole lot of experience around virtual workloads and virtual machines and such. If you do have a lot of experience with that, hang with us because we're not going to spend a lot of time on that. I just want to lay the foundation before we get into everything about cloud. So from there, we're going to talk about on-prem data centers and everything that goes into an on-premise data center. And then that's when it starts to get good, right? Because then we dive into the cloud. What is the cloud? And for a lot of us, if we are asked to define what exactly the cloud is, might not have a good answer for that. And so we're going to give you a solid definition of what a cloud service is. So if you want to know what the cloud is, hang with us. We're going to solidly define that, leave no doubt in your mind. From there, we're going to talk about the world of cloud. We toss a lot of cloud terms around. A lot of those cloud terms are going to fit into either a cloud service model, and, spoiler alert, that would be things like infrastructure as a service, platform as a service. We hear these terms IaaS, PaaS, and SaaS tossed around. That would be a cloud service model. And then we also have cloud deployment models, such as public and private and hybrid clouds. So now if we have time, I'm going to go into a little bit more detail on what the difference is between the different cloud deployment model types. But, we'll just see how we do here. We've got an hour to unpack as much of this as we can. And again, as we can see, we've got a full slate as usual. So let's go ahead and dive right in. Oh, and just a reminder as well, this video has been pre-recorded. So even though it's being premiered live on YouTube, I am in the chat. So if you have any questions at all about this section of the blueprint, or really any section of the blueprint, again, this is a study group. So if you have any questions about spanning tree or EIGRP or anything like that, feel free to toss those questions into the comment section, into the chat. And I'll do my best to respond to that and answer that. But of course, also, if you have any questions as I'm explaining things here on the whiteboard, chalkboard, I suppose, feel free to chime in with those into the chat as well. All right. So moving right into the world of cloud, which really starts again with the world of the data center. So let's just go ahead and define for us what exactly a virtual world looks like, because this concept of virtualization is not unique to the data center. It's not unique to servers. There's network virtualization. The concept of virtualization is taking a piece of hardware and carving it up into sort of virtual instances of that hardware. And there should be a very popular network virtualization technology that we are all familiar with. And if you're not familiar with this, you probably shouldn't be studying for the ENCOR. You should probably be looking at I guess the CCENT is gone, but the CCNA or even the CCT. This concept of a virtual local area network, or a VLAN. All right, we're most of us, again, if you're studying for the ENCOR, we are all aware of what a VLAN is. A VLAN is just a broadcast domain, right? It's a subset, we could talk about it being a subnet, broadcast domain, all these different definitions, but really what we're doing is we're taking a physical switch and carving it up into multiple virtual switches, so to speak. Well, a physical switch has a CAM table. What does every VLAN have? Has a CAM table. It's like it's its own little private virtual switch, and as a port comes in, we assign it to one of those virtual switches, so to speak. So, and I'm using the term virtual switch. That's not the right word for it. It's just an example, but we're bringing ports into a virtual local area network. So we had a physical LAN, now we have a virtual LAN. The exact same concept is going to apply in the world of servers. we used to have this concept that we would need a single physical server for most applications in our network. And the story I usually like to tell with this is, I've got this PC running right now. I've got my drawing application running. I've got my Chrome running over here with all my notes in it. I've got over here my OBS running that's doing the recording. And of course, if I look down in my taskbar, I've got so many other applications running right now. I probably should have closed some of those before I started recording, because applications suck the resources on a PC. And so even though PC operating systems like Windows and even Mac OS and Linux, I didn't mean anything by saying even Mac OS, by the way, and just, example. Anyways, any PC operating system is going to be able to handle running many applications at once. And server operating systems are the same way. If we don't have experience with server operating systems, guess what? We're going to find a lot of the same examples. We have Windows Server. Windows Server is simply Windows for the server world. We also have Linux. And, well, really that's the primary two operating systems we're going to see out there. There isn't really a Mac OS in the server world. But either way, we can run multiple applications. If this is my hardware, let me do this. I'm going to erase this real quick. Give me a little bit more room to draw this out. So the idea, pen working? Good. All right, so the idea here is that if we draw this like a stack, I've got a piece of hardware. That would be actual metal, an actual server, or an actual PC, or what have you. And then I'm going to install an operating system onto that. And I know that, again, my PC right now is running a lot of different applications. Application here, application here. Again, Chrome, OBS, all of these different apps are running all at the same time. The operating system is built to handle that. But in the enterprise space, this doesn't fly. Why doesn't this fly? Well, the reason it doesn't fly is because if I install multiple enterprise applications, like my email server onto an operating system, and then maybe my a web server, and then maybe an ERP system or something like that. If I deploy all these different enterprise applications onto one server and one operating system instance, number one, you're going to have some, call it soft problems, in that they're all going to want CPU, they're all going to want memory, and there might not be enough resources to go around. And you're going to call, this application vendor up on the phone and say, hey, your application's running slow, and they're going to look at your server and say, wait, you're running all these other applications. Call us back when our application is the only application running, because we can't control those other applications, and we can't control the amount of resources that they need. So that's kind of like the soft issues. Here's a hard issue. We only have so many network ports to go around. And if I install two different applications that are both running web servers, even if it's just you're going to access the application via a web tab. I pull up a new tab in Chrome and I go to use this application via its web interface. Well, all of them need port 80 open, potentially, or whatever port I'm going to open in that range. And they can't all have port 80. If port 80 lands on the server, it's got to know which application to give it to, and only one of those applications is going to be applicable for that or be available to that. And so we start to actually have some hard limitations about which applications could actually run on the same operating system instance. So this is a problem. We can't run multiple operating systems in the server world. And so what we really end up doing is, if I just erase this again a little bit, what we really end up with here is this this type of stack. One application to one operating system instance to one piece of hardware. And this was the data center world in the mid-2000s. Every single application had its own operating system instance and its own piece of hardware. And this just was a terrible use of resources. We'd have pieces of hardware that are running just a web server, and so it'd be sitting at like 10% CPU cycles and maybe like 15% of its memory. And so we're buying all of the CPU and memory, and it's just sitting there wasted. Not to mention hard drive space, by the way, but that doesn't really tie into this conversation. Either way, the world of virtualization came into play, just again, sort of like, think about this from a networking perspective. If I needed multiple broadcast domains back in the early 90s, what was I going to do? I was going to have to buy three separate switches let's say, for 3 separate broadcast domains. So I could have HR and finance and IT or what have you on 3 different sets of switches. And I might buy 3 different 24-port switches, and I only really need like 5 ports on each switch. So I deploy those 3 different switches. I've got my users 1, 2, 3, 4, 5 on each one of these, even though these are all 24 ports. So I'm wasting 19 ports on every single switch. Wouldn't it be better to put all 15 of those ports on one switch and then use VLANs to segment the broadcast domains? Okay, we understand this from a networking perspective. The same concept applies to virtual machines in the virtual server world. So this is what we're going to do. We're going to, instead of calling this a piece of hardware, we're going to maintain the relationship. Okay, we still need one operating system instance to one application. That ratio needs to stay the same. But instead what we're going to do, let me just clear this. Make it easy on us. All right, so instead what we're going to do is we're going to take one piece of hardware. At some point, like, we live in a virtual world, but at some point we have to deploy hardware, okay? It just is the reality. We're going to take one piece of hardware. We're going to install on it, instead of an operating system, we're gonna deploy something we call a hypervisor. Now, for you and me who aren't, we're network engineers, we're not server people, you can think of the hypervisor as the operating system. That's basically what it is. You get a new server, a new piece of hardware, and I can install Windows, I can install Linux, or I could install a hypervisor. Hypervisor, think of it again as an operating system. Trust me, we dive into the weeds. Server people and virtualization wizards would have probably a lot of issues with me calling it an operating system. But again, just at a high level, that's basically what we're doing, is we're installing this hypervisor. And you've probably heard of some of these hypervisors. Very popular ones. VMware. VMware makes a product called ESXi. Most of us just call it VMware. We don't call it ESXi, but if you've heard either of these phrases, this is what this is. It's a hypervisor. Microsoft makes one. Microsoft's version is called Hyper-V. Hyper-V. I don't know why they called it Hyper-V. I mean, clearly they took like the first 6 letters of hypervisor and just called it Hyper-V, I guess. I have no idea, but kind of an interesting one there. And then Red Hat, by the way, has, they take Linux, which is an open, framework, I suppose, an open source. And there's an open source version out there called KVM. Well, they have an enterprise version of KVM. KVM would be an open source hypervisor. So it stands for kernel virtual machine. The word kernel with a K is a big Linux concept. So kernel virtual machine or KVM. These are probably the 3 biggest ones. Citrix does have one out there called Zen Server, but they're not major players in this space. At least I'd say anymore, but I don't think they ever really were. Usually if you're going to find things that are supporting different virtual or hypervisors, it's going to be one of those 3. And so from here, what we're going to do is now we're going to install multiple instances of operating systems. Lots of different instances of operating systems on this one hypervisor. This hypervisor is able to handle the installation of many different instances. And these instances are called virtual machines or VMs. Again, a lot of us, even if you're not super familiar with any of these concepts, you've probably heard of this concept of virtual machines. And there goes my camera. For those who are regular attenders of this podcast study group, you're well accustomed to the fact that my camera can only stand for 30 minutes at a time. So I must have turned my camera on early because we're only less than 15 minutes into this video. But you can rest assured that I will be turning it back on again in 30 minutes. So my operating systems are virtual machines. That's basically what it is. A virtual machine is an operating system instance. And they have to be hosted on a platform that can support many different operating systems at once, and that would be that hypervisor. And then again, remember that one-to-one relationship. We're going to install our applications onto each one of these operating systems. Now, if you're paying attention, you're looking at this and saying, okay, Jeff, that's great and all. You just told me we had problems from an application presenting multiple applications sharing the same piece of hardware because of resource contentions. And that is true. But, and so some of those problems could still absolutely remain. But the reality is, in most cases, once we took those applications and split them across to those many different pieces of hardware, remember what I said about CPU instances might be running at 10% and memory might be running at 15%? Well, if we load this piece of hardware up with a ton of resources, and when I say a ton of resources, I'm meaning like modern day servers are going to have like 32 cores or more of CPU processing. 256 gig is probably the minimum amount of RAM that we're going to deploy. Regularly, it's 384, 512, and even a terabyte of memory is installed into modern day virtual hosts. And so we have a lot of resources, and we're going to put as many applications, as many virtual machines really at this point, as many virtual machines onto one piece of hardware as we can from a resource contention perspective. And the hypervisor usually has tools to help us manage the resourcing. So it's going to know that, hey, we're peaking out our memory. We're over 80% memory. That's not great. Maybe we want to consider moving some virtual machines around, which we can do. Okay, so that's problem number one. Problem number two, you're saying, okay, well, Jeff, wait a second. That is the soft requirement. What about the hard issue with like ports? And we can have multiple ports, right? I mean, if I've got port 80 open on this operating system, it knows to hand it to that application, and I could do the same thing here. And that's well and good, other than what about the actual network connection, the physical network connection that's coming in, and we have a destination port of 80. Well, what are we going to do with that? Well, we're going to switch that like normal, but the way we're going to do that, let me erase the word hypervisor here. What we're going to do that is we're going to have now a virtual switch, or a vSwitch. This virtual switch is truly a virtual instance of a switch that virtually connects all of these different virtual machines. And so when this physical network connection comes in, it's going to get mapped to a port on that virtual switch. And even though we got a destination port, we also have a destination IP address. So that's well and good. But the switch is running at layer 2. Well, again, we're going to have a destination MAC address as well. Sorry, I just looked over and realized I wrote right underneath myself. I always forget to cross that thing off. Okay, so what I had written earlier was Red Hat KVM, that kernel virtual machine. All right, very good. So that destination MAC address is going to tell this virtual switch, which has an actual CAM table, and it's going to have an actual, MAC to virtual port mapping. It's going to see that destination MAC address and forward it to the appropriate virtual machine. So even as multiple ports or multiple connections arrive that are destined for the same port, well, all of those packets are going to be destined for a specific MAC address, and they're going to be forwarded out the appropriate interface at that point. These virtual switches, again, are usually layer 2 only. They're not going to be doing layer 3 switching, SVI work. All of that is still going to be upstream of the server, which is, backwards in my drawing because I just wrote a down arrow. But upstream of the server is where we're going to have on the physical switch infrastructure is where the SVIs are going to live. Whew. Okay, so that is the world of virtualization. If you have any questions at all, let me know. So this is a very zoomed in view of a virtual host. Let's zoom this out a little bit. Okay, next agenda item here. We're going to be talking about on-prem data centers. So before the advent of cloud, and even in this day and age of the world of cloud, we have this concept of an on-premise data center. A data center is really going to store two of our most mission-critical assets, even more and more so, becoming the most two critical assets a company can own. Number one is its data. That is something that didn't used to show up on financial reports, but nowadays it actually shows up on some organizations' balance sheets. Their data has a tremendous amount of value, a tremendous amount of worth. That could be company IP, that could be customer information, that could be, by IP, I guess I mean things like their designs, their patents, all of the company trade secrets, whatever is accessed on a regular basis by its staffing. Okay, so whatever our data is stored usually on hard drives in the data center. And then the other thing too would be our applications. So our applications is less of something that's going to be of external value, but it is the wheels by which our machine, our company churns. So if, for example, our data center were to go down, nobody has access to the data, but what about the applications? Can a nurse check the EMR system for information on a patient? No, they can't. Can receptionists check people in? In a lot of cases, no. Can salespeople access their customer, their CRM tools? No. I mean, if we don't have access to our applications, we can't do business on a day-to-day basis. And, that's even excluding communications applications. Email, we all still use email, but things like Slack and Cisco Spark or WebEx Teams and Microsoft Teams and all these communications applications are also down now. Not to mention sharing applications, SharePoint and such. The list could go on and on. Clearly, these are two very mission-critical assets, again, for every organization. And so the reason why we store them in the data center is to keep them online and available at all times. That's the goal of a data center. And so this is why we see data centers often securely locked down, sometimes even with guards posted at a lot of big data centers. Not everybody has access to the data center in most cases. It's behind a lock and key or scanning your badge or what have you. And there's usually some pretty good siloing as far as, hey, the server people can go in and do this, and the networking people can go in and do that, and you're not to mess with each other's stuff, okay? We deploy networks with massive amounts of redundancy. So I guess that's the purpose of what I want to talk about here is everything that goes into managing a data center. So everything we just talked about security. That would be physical security, sure, but also network and cyber security. So making sure our servers are all running antivirus and making sure our firewalls are configured. And, we have to worry about east-west security in the networking world. That would mean, can two servers on the same subnet, on the same VLAN talk to one another? And do we want them talking to each other? And can we stop them from talking to one another? I mean, that's a huge topic alone. And that's just the first thing we're mentioning here. I just started to mention that the network is going to be highly redundant. That is absolutely the case. We want to make sure that we have extraordinarily resilient switches in there. Cisco makes Nexus switches for the data center. Nexus, to this day, has a more resilient operating system than iOS. The way they architected NXOS is very different than iOS. It's why they run two different operating systems. They feel mostly the same. There are some differences for sure. But ultimately, Nexus are just designed to be better switches, more resilient switches. Plus, they're going to have protocols that are run only inside the data center, like fiber channel over Ethernet, and virtual port channeling are all going to show up in the network. We, of course, are going to have servers. Now, we have to be careful with the word server because we just looked at the fact that we have these virtual machines, which are virtual servers. We also had physical servers. So what we're going to find here is that the physical servers we're going to call virtual hosts. I believe I'd already said that once or mentioned that term, but a virtual host would be a physical server that hosts many virtual machines. And the virtual servers are either going to be called VMs, but there is technically a phrase that we use called guests. And as far as vernacular is concerned, I hear all the time virtual hosts be said. I don't hear a lot of people refer to virtual machines as guests, but I have. I mean, and I do, and others can, and that's a perfectly fine phrase. So whether you hear it's called virtual machines or guests, either way, that would be the two different kinds of servers that we have to manage in this environment. So on top of the virtualization of the servers, we have to worry about that hypervisor. So the hypervisor, whether it's VMware or Hyper-V, and whether we want to migrate from one to another and keeping it all up to date, the software and the patching, large organizations will sometimes just differentiate from the server team and the virtualization team. And that's because they have way more on their plate with just managing the virtualization, the hypervisors. They can't actually help manage the servers. They just don't have time for that. Storage. Don't want to forget storage. So I mentioned earlier that hard drive space is an issue. Well, more in modern networks or modern data centers, we don't see hard drives directly attached to servers. Instead, we'll have a lot of servers that are all accessing through the network a storage device. So this network storage appliance, we think of vendors like NetApp, EMC, Dell has a whole line of server or storage devices. A network-based storage array is going to put all of the hard drives here and none of the hard drives up here. And so it's kind of weird to think about a PC or a server booting up without any hard drives attached. They technically can. There's ways that they can access a boot drive and boot directly off of a network-attached hard drive. This takes that concept, like we mentioned earlier, of having like maybe 10%, 50%, 45% of their hard drive space consumed. I mean, if I have 10 terabytes on this one server and it's 45% consumed, then I've got 550 gig that's just sitting there unavailable. And maybe over here on the left, instead of 10%, it's at 99% full. And I could really use some of those gigabytes over here. And so the way we do that is by deploying network-based arrays. Another concept here would be hyper-converged infrastructures. For those who have heard of Cisco HyperFlex, that's a big platform that Cisco offers that basically provides this. What's weird about hyperconvergence is everything I just said is sort of undone because we moved the hard drives back into the servers. But yeah, I gotta be careful here. I'm gonna go down a rabbit trail. But the hard drives are not managed by the servers. The servers don't think they have hard drives attached. Instead, we have special software that more or less borrows the server shells to say, I'm going to store my hard drives in these servers, but I'm going to turn around and present the hard drives back to them as a giant pool of storage. So if that made sense, great. If it didn't, then trust me, it's a much longer conversation and worth having. And go watch some YouTube videos on hyperconvergence and especially Cisco HyperFlex, which in my opinion is like catching lightning. I mean, it's a phenomenal product, way better than any of the other hyperconverged platforms out there, but I might be a little biased. Who knows? On top of all that, we've got this kind of ties into security a little bit, just from the perspective of we're trying to keep everything online. So I just think about anyways, it has to do with this part, right? Trying to keep everything online. Backups and disaster recovery, two very distinct concepts that often get grouped together, but again, mutually exclusive. Backups are all about restoring lost data. Disaster recovery is all about getting back online as fast as possible in the event of a disaster. We can use backup systems as our DR plan. It's not usually the best idea, but again, it's all about keeping us online, not losing any data. I mean, it's bad enough, losing a spreadsheet you've been working on for an hour, right? I mean, that feels like a sock in the gut. The last thing we want to do is lose months of data or weeks of data or even days of data, especially when, things like ransomware exist out there and it could lock us out. We have to go really far back in time to recover data. I mean, that's bad news. We want to keep all of these systems in place as best as we can in order to keep our data and our applications online and accessible. Okay. If this conversation didn't result in you feeling like your head is spinning, then maybe data center is a great place for you. I got to say, I love the data center. I mean, I have this conversation I could have all day long. I love data center technology. I've spent a lot of time doing data center designs and data center deployments. And again, talk about awesome technologies like Cisco UCS, which is a server platform, or HyperFlex, which is hyperconverged platform. I love NetApp storage. Anyways, it doesn't matter what my personal vendor preferences are. All that to say, it's really fun to bring all of these different technologies together and make them work. But there is a certain amount of stress involved because if we lose data, our applications go down, our organization suffers. And I've spent some time talking in previous study groups about this idea that we need an IT. We get so wrapped up in the bits and bytes and technology, I guess. We get so wrapped up in our own stuff that we forget that we are maybe a medical clinic that services patients, or we're a financial organization that helps people with their retirement accounts, or maybe we're a restaurant chain and we actually serve food to people. I mean, we have this tendency to forget that we have a front lines. And we're really the guys in the back, the man or the woman behind the curtain, so to speak. That's who we are. And our job is to keep that online, because if this goes down, our customers hurt, our organization hurts. If we lose enough money, people might lose their jobs. I mean, this affects real people, and that's where the stress can come in. So, all that to say, about halfway. Good, perfect. We're on schedule here. All that to say, in a lot of cases, this is why organizations are looking at cloud solutions. Because cloud solutions say, all right, all of this right here, this is a headache and this is stressful and I don't want to manage this myself. And so companies like Amazon is a very popular cloud service. Amazon is a very popular cloud service provider. Microsoft, very popular cloud service provider. A lot of different organizations have said, hey, move your virtual machines up into the cloud, and at that point, we will do all of the other things. So if we look at this, if I just move a virtual machine into a cloud space, then I don't have to worry about security as much. They're going to present a lot of security technologies to me. In other words, like I might not have the capability of managing east-west security inside my own data center, but in the cloud I do, because they've got the systems in place to make that happen. And all I need to do is make a few clicks and boom, my security profile is deployed. The networking, I don't need to worry about network switches and performing network upgrades and scaling out to buying more network switches to support more servers. The servers themselves, I don't have to manage hardware anymore, dealing with hardware failures and procuring new equipment. What if I start to run out of server space? Well, that's not, in a cloud space, that's not for me to worry about. That's for the vendor to worry about. All I know is my virtual machines are online and functional. I don't care how many physical servers they have. I don't have to manage Hypervisor anymore because, again, I'm just managing virtual machines. And same thing with storage. So pretty much all of this goes away to some extent in a cloud service. Now, that said, as you can imagine, I like to liken this concept to a valet service. I mean, I think I used a valet service once. But either way, it's nice. It's a convenience, right? You pull up to a hotel and there's somebody standing outside and they're like, hey, for $10, I'll take your car and I'll park it for you. And then when you're ready for it, I'll go get it for you and bring it back to you. And so you don't have to walk all the way to the parking lot or what have you. And you can unload all of your luggage and suitcase and everything right there. Those valet services are really convenient. I don't have to park my car. I don't have to retrieve my car. I can unload everything right there. But it comes at a cost. I have to pay $10. I can self-park for free, but I can pay somebody else to do a bunch of stuff for me. Okay? Cloud world is the same concept. There is a big misconception out there that cloud is cheaper somehow. That I move all my virtual machines to the cloud, and because I don't have to buy servers, I don't have to buy networking, and I don't have to buy hypervisor licensing, and I don't have to buy all these systems, that somehow it's cheaper. Well, no, it's not cheaper. I'm paying for all of that stuff. The cloud service provider is installing network switches and they're installing physical servers and somebody's paying for that. And guess who's paying for it? Okay, this guy. You and me, we are paying for it. And so any cloud cost analysis over the course of 5 years, or even over the course of 3 years in most cases, you're going to pay more money for a cloud service. But look at all of the things that you don't have to manage anymore. That is the value, and that is why sometimes it's worth it to move into a cloud space. Okay? There's also this concept of CapEx versus OpEx spend. We don't have time to go into that, but the gist of that is cloud also is just kind of that monthly subscription. I pay maybe $15,000 a month regardless of anything, whereas in IT, I might not have to pay nearly that much a month up until I get the call, we're the tech, right? So we have to make the call to the CFO. Hey, CFO, I need another $100,000 worth of network switches or servers or what have you. And so, their life is dealing with this kind of flow where I'm spending very little and then boom, I spend a bunch of money in 1 month and I'm spending very little and then boom, I spend a bunch of money in 1 month. Those are CapEx spends. And CFOs, as you can imagine, don't like living with that stress any more than you or I would managing our personal finances. I'd really rather subscribe to a service for $10 a month than once a year have to pay $100 a month. Yeah, I end up spending more. I spend $120 in the year. But from a finances perspective, it's a whole lot easier to manage a $10 monthly line item than it is to manage once a year, boom, $100. Like that's hard to budget for. Hopefully that makes sense. I said there wasn't enough time to cover it, and yet I covered it. So there we go. Okay, moving on. We are ready to talk about what in the world a cloud is. Okay, I promised we were going to offer a very clear definition, and we are. In fact, we're going to borrow somebody else's definition, and that would be NIST. Okay, NIST is an American organization that I'm blanking on the That it's the National Institute of, it's not Science and Technology, Standards and Technology. That's it. They like to define standards within the world of technology. And so even though it's a national, even though it's an American institution, they created a definition of terms of what the cloud is that is used pretty much worldwide. Okay, it's a pretty good set of definitions. It comes down to 5 different concepts. So, what is a cloud service? A cloud service is going to have these 5 characteristics according to NIST. Okay, first of all, it's going to have this concept of on-demand self-service. On-demand self-service. What is on-demand self-service? So here's the concept. Each one of these, I want to compare it to a traditional network, versus what it modern day is. Let's say we have an application developer in a traditional network, and that application developer needs a new virtual machine. Okay? Do we usually give our application developers and our HR reps and our financial team and our legal team, do we give them direct access to our technology interfaces? And the answer is typically no. So how is the poor developer supposed to get a virtual machine? Well, in traditional networking, in a lot of cases, they'll call the help desk, say, hey, I need a virtual machine. The help desk will say, all right, cool. I'll enter a ticket. Now we've got that ticket in. You will get your virtual machine. And then somewhere between maybe an hour and maybe 3 days later, they get their virtual machine. Now, I don't know about you. When I call up, think ahead and do your due diligence and do your planning. That sounds good. But I tell you what, there are times when I'm like, all right, I'm sitting down to do my work and, oh no, I didn't call that person and tell them I need this. All right, hey, can I get that virtual machine spun up like in the next hour? Oh, it's going to be 3 days. Okay, well, shoot. And now, so I'm all ready to work on it, even if it's an hour, let alone, a 3-day period, right? Like either way, it kills my momentum and it kills my productivity to have to sit and wait for that service to be delivered to me. Okay, compare this to a cloud service. A cloud service, imagine if Amazon, who spins up virtual machines for people, imagine if I had to call Amazon and say, hey, Amazon, I need a new virtual machine. Imagine how many calls they'd be fielding. Imagine how obnoxious that would be for most people. No, instead, we know when we get this, I'm going to pull up a website and I'm going to click a button that gives me a virtual machine. That is self-service. What does on-demand mean? On-demand means anytime I want. Middle of the night, weekend, whenever. Holidays, Christmas morning, I want to spin up a virtual machine. Amazon services there, spinning up virtual machines on Christmas morning. God bless them. But it's automated systems that are doing it. I was speaking to a local municipality once about their cloud experience. They were using a local cloud provider, and one of their big frustrations was, anytime we want to add, spinning up virtual machines was on demand, they could do that. But anytime they wanted to, let's say, add storage to their storage pool, they had to call the company up, and that company ran 8 to 5 Monday through Friday. That was it. So Saturday afternoon, they're going in to do a cutover. They're going to do this big upgrade, and they find out they don't have enough storage. Now their upgrade is canceled on a Saturday night because they can't provision more resources into their cloud pool. This wasn't an on-demand service, right? It was self-service, yes, but it wasn't on demand. They could. Yeah, I believe that is how it worked. I had to catch myself there. They'd log into the system and they'd provision, request more resources, but somebody on the other end had to actually accept it. So all that to say, they were looking at moving away from that provider because it wasn't convenient enough. Again, an Amazon or even most regional or local cloud players will be on demand these days. Okay, so on-demand self-service, number 1. Number 2, broad network access. Broad network access basically means I can access it from anywhere. Now, the most common example here from a traditional network perspective would be VPNs. Okay, we in the networking world, we're very comfortable with the concept of a VPN, right? I'm going to fire up my VPN and connect to my business network, and then I've got access to all of my resources. users are not super great with VPNs. It's just one more process that they have to do, one more application. And again, they don't understand why. They don't understand what a VPN is. Like most of us in the networking world, we understand what a VPN is, why it is, and how we access the VPNs. So it's hard for us to, we have that curse of knowledge concept where it's hard for us to step into the role of a user who doesn't understand those things. And so they're needing to VPN in to the network in order to access something. So let's say in our private data center, we had on-demand self-service, and we can do this in a private data center. Cisco's got tools that we can deploy that allow people to go out and provision their own virtual machines. It's fantastic. But what if I have to use a VPN to log into this on-demand self-service? Well, that's no longer, in this definition, that's no longer a cloud service. So one thing to keep in mind in all this is if we want to call our data center a private cloud, like a lot of places do, a private cloud needs to have all of these characteristics. Otherwise, it's not a private cloud. It's just a data center. Okay. So on-demand self-service, broad network access, again, accessible from anywhere. I can access Amazon or Microsoft from the Starbucks, from my house, from my company network, VPN'd in, VPN'd out, anywhere I can access these resources. So that is broad network access. Incidentally, by the way, that is not to say that my virtual machines are accessible anywhere. I should not be able to access my virtual machines from anywhere in the world. That's a big security threat. It's saying that the service is available from anywhere in the world. Okay. Resource pooling. Come on, there we go. Resource pooling. So resource pooling is more or less what we've been talking about with saying that let me think of an example here. So the idea is saying I have, let's say, 100 terabytes of storage. Okay. I don't care where that 100 terabytes of storage lives. It could be 15 terabytes on that storage array, 25 terabytes on that storage array, 10 terabytes on that server. I don't care. I just know I have 100 terabytes of storage. And every time I install a new virtual machine, or every time my virtual machine goes out and downloads a bunch of data, that resource pool ticks down. Same concept with CPU cycles and memory consumption and even network bandwidth in a lot of cases. The idea is simply, here's your pool of resources, use it how you see fit. And this is a challenge in traditional infrastructures because, here's why. Because there's one more aspect to the resource pooling. It has to do with that story I told earlier. Let's say I have 100 terabytes and now I'm approaching 95, 96 terabytes. So I'm just going to go out and I'm going to grab another 50 terabytes and put it into my infrastructure. So I can just increase the size of my pool. And that company, that municipality, they were not able to do that seamlessly. Well, in a private cloud, so to speak, in a data center solution, it's very hard to do this because we might be able to pool our resources as best we can, but there's no guarantee that we're just going to be sitting on more resources. So I might have a brand new storage array, it's 100 terabytes and provisioning it out and life is good or life seems good. And then my HR department goes out and buys a new application that needs 50 terabytes on its own. And so I might have to go out and buy more storage in order to support that application. It's really hard to get away from that because, told you it was going to go away. It's really hard for us to get away from that in the data center space because we don't want to just sit on a bunch of hardware. We don't want to go out and buy, an exabyte of storage just in case we need it. But that's what all of the cloud providers are doing. They're sitting on exabytes of data. So if you need to go out and spin up an extra few terabytes or whatever, they've got that sitting and ready and available at any time. Okay, so that's the advantage of going with a public cloud, for example. All right. The other aspect, by the way, and this is sort of a sub-bullet point, is this concept of multi-tenancy. All right. Multi-tenancy is, well, at least the idea of multi-tenancy is that I've got a lot of different clients running on one physical infrastructure. So as you can imagine, again, Amazon and Microsoft, they're going to have one physical server with virtual machines from my company and virtual machines from another company and virtual machines maybe from a direct competitor, right, of mine. They don't care. They're just throwing virtual machines out onto servers, which means, by the way, that we're all storing data on the same physical hard drive, which means we're all using the same physical network uplinks. Okay? Multi-tenancy means we're all sharing resources in this environment, but we still have the security of not being able to access each other's stuff. Okay? So that's the concept of, again, resource pooling. Multi-tenancy is kind of a part of that conversation. Okay, rapid elasticity. I think I jumped the gun a little bit on the resource pooling concept. Obviously, these two are tied together a little bit, but the idea, wow, this is a heck of a Y. What did I do there? That's amazing. Elasticity. All right, there we go. So rapid elasticity more or less means I can stretch my environment up and I can compress it down at any time. So if I need 100 terabytes today, a better example might actually be if I need, let's say, 10 terabytes of memory. I'm using 10 terabytes of memory across all my virtual machines today. Tomorrow, busy season hits, it's Christmas season or prom season or whatever it is that makes my business spike up. And all of a sudden I need 15 terabytes, 50% more for this season. So I'm going to pay, which we're going to get into next, by the way. So I'm going to pay for this 10 terabytes, and then I need to stretch really quickly to 15 terabytes for this season, for 3 months, let's say. And after 3 months, boom, I go back down to 10 terabytes. This elasticity up and down is a key part of a cloud infrastructure. So when I talk about rapid elasticity, that's what we mean by that. Okay, and the last component, this is fancy. It's called measured service. Sounds fancy, basically means I pay for what I use. Okay, at home here, I pay for my water use, and I pay for my electricity, and I pay for maybe gas consumption, natural gas, and I pay for what I use. If I use less electricity, if I were to actually shut down my studio for a month, I would probably use less electricity that month, and I would pay less. Okay, same thing with cloud. They need to be able to measure how much you spend, how much you consume, so that they can bill you for the appropriate amount. I don't want to have to pay for twice as much electricity if I didn't use it. So if the electric company has bad measuring practices and they think I'm using more than what I spend, then I'm going to eventually, well, I don't know if I can leave my electric company because there's kind of only one in town, but you get the point, right? With the cloud world, I can just flip my servers over to somebody else. And so they need to have accurate measuring tools in place so that they can appropriately bill according to what I use. Okay. In the private data center space, this is it's an interesting one. Okay. There is a use for this in on-prem data centers, and the concept is basically this. I might have different departments, let's say HR and finance and what's another department? Legal team, I guess. And what we can do is this concept of chargeback. Yeah, let me put it up here. I don't have much space. I gotta not draw underneath me today. Okay, chargeback. This concept of chargeback is saying that I'm going to track what each department uses in my data center space, and I'm going to charge back to those departments what they consumed. Now, that sounds really weird to say I'm going to charge a department for consuming IT resources. But the interesting thing with this is that IT is typically its own cost center. And IT is generally viewed as a drag on the bottom line. As an organization, I've got to pay my IT staff and I've got to buy IT equipment, and it's just a drag on the bottom line. And what a lot of companies tend to forget is, you spent $1 million in IT stuff, but that $1 million went to enable your HR department. It went to enable your legal department. It went to enable whatever. And so this concept of chargeback, basically what organizations are doing with it is they're removing IT as a cost center and saying IT costs $0 and it spends $0. It's just IT is neutral, which should be actually part of our mindset anyways, but it's not often because of how much it costs in the world of IT. So IT is no longer a cost center. Instead, I'm going to make IT budgets as part of each one of these departments. And so HR now has an IT budget spend. And so let's say I gave them, of my $1 million, I gave them $200K. So now HR department has 200K. Well, I'm detecting how much you spent, and you actually spent $210,000. Where's that extra $10,000 coming from? Well, it's coming from your cost center HR, and now you can't buy as nice of a Christmas party for your team, I guess. I don't know. Christmas bonuses go down, whatever the situation is, right? But it shouldn't be my fault. If I'm in IT, and we're all used to this, right? We need another network switch. Oh, we need another server. Oh, we need another extra set of storage. Is it usually IT's fault? I mean, every now and again, we don't plan ahead very well. But in a lot of cases, the growth is the growth. And if the HR team deployed a new application we weren't expecting, and we need more servers as a result, well, that looks really bad on me to go in and say, Mr. CFO, I forgot, or I didn't realize this was going to happen, and I need more servers. I know we just bought $50,000 in servers, but I'm going to need another $30,000 in servers based on what just happened. And I can try to say it's because of HR. And in most cases, it's not one thing that caused the problem or that caused the cascade. It's a little bit of this, a little bit of that, a little bit of another thing. Maybe 5 different departments all added just enough so that now I've got to go buy more stuff that I wasn't expecting. And again, that CapEx spend concept, the CFO wasn't expecting it, and they're not going to be happy about it, and I look like the bad guy. In this chargeback model, we eliminate all of that. Okay? HR spent a little bit too much. Finance spent a little too much. Legal spent a little bit too much. And the good news is, if they all spent that $210,000 instead of $200, well, now I've got a $30,000 budget. That didn't show up. A $30,000 budget that I can go out and buy new equipment. That I got $10,000 from each department's cost center, so I can go out and make the necessary spends. And now, if anybody's the bad guy, it's the people who used the resources. But generally speaking, as much as anything, it shows an organization where their technology spend is going and the value that it brings. So that's why I'm a huge fan of this. I've not seen it deployed a whole lot outside of very large enterprises, but it's a really neat concept to be able to say IT is no longer a cost center, it's no longer a drain on the bottom line. IT is now just simply a part of every department's budget. And chargeback is how we get there. Now, the downside to chargeback is it's really only applicable here, or at least easily measurable from a cloud perspective. It's hard to deploy this or push this out to all technology stacks, PCs and network switches, closet switches, etc. But it can be done. It definitely can be done. Whew. Okay. Coming up on our time here. So let's move on to the next topic. We're going to kind of blaze through these. Might go a few minutes over. We'll see. Shouldn't be too bad. I did not add a new layer. There we go. Okay. So, cloud service models. We're going to talk about, let's just talk about cloud service models. Okay, this is a pretty important concept because it gets tossed around a lot. Okay. Not all clouds are created equal. If a cloud service has those 5 characteristics that we just saw on the previous screen, then it's a cloud service. But not all cloud services do the exact same thing. So that's where we get into this concept of cloud service models and cloud deployment models, and usually we can categorize a cloud service as, into various options here. Cloud services models. Mentioned them earlier. Infrastructure as a service. Sometimes the A's are capitalized, sometimes they're not. We have platform as a service, and we have software as a service. The gist of these service models is going to be, how much do I want to manage myself? I don't know how to very quickly, me? I don't know if that worked or not. What do I want to do? That's what I'm trying to say here. What do I want to do? Infrastructure as a service is interesting because I have to manage. We talk about virtual machines a lot. All I have to manage is the virtual machine. That seems pretty good. All of that stuff on the first slide, the networking, the servers, the storage, I don't have to manage any of that. I just have to manage a virtual machine. And that sounds good, except from a cloud perspective, that's actually the most I can manage. They're not going to let me manage network switches and firewalls and storage arrays and such on their network. That makes sense, okay? But can I manage less? That's the question. I'm going to skip platform as a service for a moment because it's a little bit nebulous. Little cloud humor there. Hard to define platform as a service, but you kind of get a sense of what platform as a service is once we define software as a service. So what's software as a service? Software as a service says I'm only going to manage the software itself. So when we think about it, what does a virtual machine look like? Well, a virtual machine has an operating system and it has an application. So that's interesting. So what am I managing from a infrastructure as a service perspective? Ding, ding, ding. I've got to manage the operating system. Do I want to manage a bunch of Windows server instances? Do I want to manage a bunch of Linux operating system instances? That's the question I have to ask. What do I want to do? What do I want to manage? Okay. Infrastructure as a service says I'm going to manage the entire virtual machine, operating system, application deployment. I've got to install the application myself, etc. Software as a service says I don't have to manage the operating system anymore. I only have to manage the application. Cool. That's actually pretty neat. Now, a great example of software as a service, the reality is that many of us use software as a service at home in some level. Software as a service usually has the mark of not having to install anything onto your machine. So I know that about a year and a half ago, my wife and I were done managing budgets on spreadsheets. We decided to sign up for an online budget, or we'll call it online, or trying to avoid the word online, failure. A budget software program. Now, it used to be 10 years ago, you'd go out to the store and you'd buy a budget application and you'd take it home and you'd install it onto your machine and you'd do all of your budgeting on the software instance. But nowadays, I'm using a software as a service. That means that I didn't have to install anything. I didn't have to buy anything. I just subscribe to a service and I log in via the web and I do all my budgeting on there. All of the CPU and all of the memory consumption, everything that application takes is in somebody else's data center. It's not on my PC. And plus, I can access my budget from my PC. I can manage it from our family PC. I can manage it from my phone because it's software as a service. The software is running somewhere else. I just have to manage my own budget, right? So that's software as a service. So infrastructure as a service, software as a service, we see the difference here. Where does platform as a service, right? Because there's just an application operating system instance. I mean, it looks like it's right between the two, and it is. It's sort of between the two. What we have to realize about platform as a service, and something I didn't mention earlier, us as network engineers might not fully appreciate this. Not every application requires only one virtual machine. In a lot of cases, I might need 3 different virtual machines to run a particular application. One of these virtual machines, this one might be a web server. I did it again, didn't I? Oh well. We'll just cross this one out and we'll put it up here. Application operating system. So one of these services, WEB. One of those servers, one of those virtual machines might be a web server. One of them might be the data server, what we call the application server. It's actually running the application. And then one of them might be a back-end database. And so a platform as a service is usually saying, I'm going to take part of an application like the database, and I'm going to manage that for you. And then I can take that database concept, I can apply it to many different applications. So it's sort of in between in that, I'm still managing some operating system instances, I'm still managing the application itself, but I'm still managing less. So it's still less than infrastructure as a service. I mean, this is the most that I'm managing, and this is the least. And platform as a service is usually somewhere in between. Okay. Do some Google searching to look at different examples of platform as a service. I think that's about all the time we have for today. Last but not least are the cloud deployment models. Unfortunately, we do not have time to go over these in detail, but as always, I mean, there's resources all over the place, not the least of which is in the CPT Nuggets course on ENCOR that will give you all the information that you need to know. All right, cloud deployment models. What are these? These are these concepts that we've already mentioned. Public cloud, private cloud, hybrid cloud, and yes, there is a fourth that is called a community cloud. Just to run through these real quick, a public cloud simply means that it is somebody else's. It belongs to somebody else. So this would be Amazon, This would be Microsoft. There are literally hundreds of cloud service providers out there, right? Pick one. My virtual machine lives inside of somebody else's data center. That's what a public cloud is. Or, given what we just talked about, it's not even necessarily a virtual machine. It's a service, a database service, or a software as a service. That is a public cloud instance. Private cloud means it's inside my data center. The key thing that I always stress here, big deal, is that just because I have a data center does not mean I have a private cloud. A lot of people refer to their own data centers as a private cloud. That is not the case unless it's got those 5 NIST characteristics. Do we have on-demand self-service? Do we have measured service? Do we have all of these 5 characteristics? And in, I dare say, most cases, we do not. Okay? So if we don't have at least the majority of those characteristics, we can't call our data center a private cloud. Or we can, but it's not a private cloud. So a lot of organizations will put a lot of effort into making their data center a private cloud, allowing their developers to log into a web portal and spin up virtual machines and such. I mean, that's all really good practice. Hybrid cloud, probably exactly what it sounds like. And that warrants a little bit more time. I'll come back to hybrid cloud in a moment. Community cloud, I might get in trouble for saying this, but unless, I don't know. In most cases, you're not going to run into community clouds. This is almost something you just need to know for exams. Okay, where you might actually see community clouds in action would be in the higher ed space. So colleges and universities, you might see community clouds. You might occasionally see them with medical research, but you're not going to see a lot of community clouds out there in the world. At least certainly you're not going to be interfacing with a lot of them unless, I guess, you already have one. But the idea of a community cloud is simply me and a set of organizations, we're all sharing resources. I guess I should have defined that. We're all sharing a data center space. It's just the 3 of us or 5 of us or what have you. And we're going to share these resources that we're all paying into or what have you. Okay. So this idea of hybrid cloud, the only thing I want to clarify with this is, yes, it means we have public cloud access. And in some cases, it means we have multiple public clouds. So maybe we have Amazon and Microsoft spun up. And then we also have a private cloud. And so we've got all 3 of these. We've got virtual machines stored on premise. We've got virtual machines stored in Amazon. We've got virtual machines stored in Microsoft. And that is more and more the reality. Cisco calls this the multi-cloud world. Multi-cloud is sort of an expansion on hybrid cloud, but their point is simply saying that we've got more than one public cloud vendor at play. And usually what we're going to try to do is deploy I know it's barely on there. Deploy a brokering piece of software that runs our data center. Anyways. And it's going to help us decide where to spin up a new workload. So I got a new application. I got to spin it up. Where should I deploy it? Should I deploy it in my private cloud? Should I deploy it in my public cloud? Where is it going to be the cheapest to run? And if it's going to blow the resources out of the water in the private cloud, or it's something that's going to spike regularly, it probably doesn't belong on premise. But if it's a very stable resource load and it doesn't take up a whole lot, it's probably going to be cheapest to deploy into my private cloud. And so I simply leverage the cloud that's most appropriate. Now, I just described that from a cost perspective. Every public cloud usually has specific reasons why you'd want to use it. I mean, that's why you'd maybe want to use Amazon and Microsoft. They both have features that the other one doesn't have. And so there's always going to be reasons, even outside of cost, as to why you might want to use one private cloud or one public cloud over the other. So that is that. I thank you everyone for coming and for engaging on this topic. It feels like it's not a networking topic because it's very data center server-minded conversation and topic. But the reality is that even though I didn't get to really go into the details of this, if I've got a private cloud and a public cloud, I have to have networking going between them. A lot of times it involves MPLS circuits being terminated into a public cloud or a VPN. And so we as network engineers, yes, need to understand the networking, but before we can even understand the networking, we need to understand why we have multiple clouds. What even is a cloud? And that is this conversation. That's exactly, in my opinion, why Cisco has included this on the ENCOR blueprint. Because if you're going to be a CCNP, you need to understand what the cloud is, because your organization probably has access to the cloud. So Again, thank you very much for joining. Next week, we are doing this is exciting. Drum roll, please. The principles of Sd-Wan. A lot of people have been asking, are we going to cover Sd-Wan as part of this study group? And the answer is yes, we will. August 26th, that's in 2 weeks from this live showing. Be sure to tune into that because it's going to be the start of a conversation around Cisco's Sd-Wan product. And it's going to be a lot of fun. There's a lot to cover with Sd-Wan as well. So everyone, I hope you have a great rest of your day, and we will see you next time. Bye-bye.